Hello. Today we will be talking about car acceleration and mainly how the acceleration of an electric car differs from the acceleration of a normal petrol-driven car. We will be focusing on the Tesla S model, which you can see here in the picture, but not so much on the Lamborghini. It's just an illustration of a normal petrol-driven car, albeit a very fast petrol-driven car. Normally, when you talk about acceleration of cars, you talk about how quickly the car can reach 100 kilometers an hour or 60 miles an hour. This is called the car's 100 to 0 time. Typically, you would think that just by comparing 100 to 0 times, you can tell which car will win a race. This is however not true, as I will be showing you in this video. Alright, let's imagine we have two cars standing in a light stop, ready for a quick race. Let's imagine that the cars would not be going much faster than 100 kilometers an hour because of safety reasons or because the race is just too short to reach that speed. Okay, let's also imagine that we have professional drivers in each car to eliminate anything coming from poor driving. Alright, let's say that car A is quicker than car B. Let's imagine this one, the petrol-driven car, to be car A, and this one, the electric car, to be car B. Alright, the petrol-driven car A, will reach 100 kilometers an hour first, but actually it will be behind when this happens. And this can seem pretty weird, but it's because of the non-constant nature of the acceleration of the cars, which I will show you. Okay, so we have car A, a petrol-driven car, which goes from 0 to 100 kilometers an hour in 3.2 seconds, and an electric car B, which does it a bit slower. Okay, let's look at the acceleration of these two different cars. Okay, this is a chart of the acceleration of a petrol-driven car versus an electric car. This is not the same petrol car as you saw in the picture, but the idea of the acceleration will be the same. As you can see, the petrol-driven car's acceleration, it varies a lot in the beginning, and this is because it has to change gears. Every time it switches gears, it loses a bit of acceleration, and it has to do this at least 1 or 2 times, about that, before reaching 100 kilometers an hour. If you compare it to the Tesla, which has no gears, you can see that its acceleration shoots immediately from the beginning, from about 0 to a bit over 1g. Keep in mind that having an acceleration above 1g means that the Tesla will actually be accelerating faster than a person would if the person would be to jump off a roof, which is pretty insane to think about, I think. The graph also shows us that the acceleration of the Tesla drops very rapidly after about 2 seconds, which means that the petrol-driven car's acceleration will be higher at about 2.5 seconds, and this means that the petrol-driven car will start getting closer to the Tesla and overtaking it. But the main thing to take from this graph is that an electric car is very, very fast in the first 1.5 seconds of a race, while a petrol-driven car needs to be going up in gears before it can really catch up to the electric car. And this is the nature of the thing I told you before, of how a car that is slower from 100 to 0 can actually be ahead when it reaches 100 kilometers an hour. Alright, let's look at an actual example. I've taken some data from the internet from 2 different cars. One, the electric car, is the Tesla P85D, and the petrol-driven car is a Ferrari 458 Italia. These cars are both very fast, but the Ferrari is faster from 100 to 0. It does it in about 3.2 seconds, as you can see, which I showed you before, while the Tesla can do it in about 3.5 seconds. Alright, but the thing we see is that the Tesla, which is the blue line, and by the way, this is velocity, it's how fast the car is going, and this is time, how much time it has taken to reach that velocity. As you can see, the Tesla velocity, it increases very rapidly in the beginning because of this very high acceleration. So it gets a lot of higher velocity than the Ferrari in the beginning, in the first 2 or 2.5 seconds. And at this point, the Ferrari and the Tesla are both going 100 kilometers an hour. So they have the same speed here. But after this point, the Ferrari will be going faster than the Tesla because it has gotten up in gears, and at this point, the Tesla's acceleration, as you saw from the graph before, has dropped quite a bit. So this is the point where the speeds intersect. But this is, however, not what we see in an actual race. What we see when we look at two cars racing, we don't see with how fast they're going. We see how far they have gone. And to analyze how far a car has gone, you need to integrate the velocity graph right here. This is what you do physically. If you have a velocity and you want to know how far the car has gone, then you integrate the graph. Integrating is equal to just seeing how much area is beneath the graph. So let's say the Ferrari does 100 to about, what is this, 80 in 2.46 seconds. The area beneath the Ferrari's curve will be how far the Ferrari has gone in this time. And the same thing about the Tesla. And as you can see at this point, right here, the area under the blue curve will be bigger than the area under the red curve because it has a higher velocity in the beginning. This means that the car, the Tesla, will be ahead. I have another graph here I want to show you, where I actually took the area under the graphs and plotted them against each other so you can see. Yeah, here we see it. We see that the Tesla, which is the blue line again, it will be going further and further away from the Ferrari at this point, where the axis over here indicates how far the car has gone in meters, and down here it's time in seconds. And as you can see, the car, the Ferrari, it won't catch up with the Tesla until about 4:45 seconds. This is quite funny to think about, since the Ferrari was actually going faster than the Tesla at around 2.5 as we saw before. So around this point, the Ferrari is actually going faster than the Tesla, but because it's behind, it will take about the same amount of time to actually catch up with the Tesla, which means that the Tesla will win the quick race. And this is data taken from professional drivers, so this is not how it will work in the real world, as driving a petrol-driven manual car is a lot harder than driving a Tesla, because you have to be very good at switching gears, which you don't have to do in the Tesla. Actually, I have a video of exactly this, the Ferrari versus the Tesla, so you can see a real world situation of what happens. And keep in mind the things I showed you here about how the Tesla is quicker in the beginning and how the Ferrari then catches up to the Tesla later on in the race. As you can see, in the beginning of the race, the Tesla overtakes the Ferrari. At this point, at around right here, you can see the Tesla is no longer getting away from the Ferrari. The Ferrari is actually catching up to the Tesla, which means at this point the Ferrari is going faster than the Tesla. It's probably going around 120 kilometers an hour at this point, but it still needs to catch the Tesla. So at this point it's going faster and faster, and at this point it overtakes in about above 10 seconds. This means that the cars are going around 200 kilometers an hour at this point. So the quick race is easily won by the Tesla, while the long race is easily won by the Ferrari. Yeah. Okay. I have a last graph I want to show you, which is the graph from before, but I have indicated the area under the graphs with these orange stripes. As you can see, the first part of the race, and this is again the velocity versus the time. In the beginning of the race, the Tesla velocity shoots ahead, and because of this, the area under the Tesla's graph is higher than the area under the Ferrari graph. And the amount that it's higher is exactly the area between the two graphs. This means that at this point, where the Ferrari is going faster than the Tesla will be this much ahead if you take this area, which will be about 5 meters. I've done that. This means that from here to somewhere in the future, the Ferrari will have to catch up this amount of distance. It does that when the area, the difference of the areas between the graphs is exactly the same. This means that when these two areas, this part up here and this part up here, are exactly the same, the Ferrari overtakes the Tesla. This happens at about 4:45, as I showed you in the graph before. Yeah, and this is pretty interesting to think about, how a car that is slow from 100 to 100, 0 to 100, sorry, or not slow, but comparatively slow, can actually be way ahead when it reaches 100 kilometers an hour. And this is because, as I showed you, electric cars have a lot of acceleration in the beginning from 100 to 60 kilometers an hour. And at this point, they can build the lead on the petrol car, even though the petrol car will reach 100 kilometers an hour first. This is what I wanted to show you today, and I hope you learned something. Thank you for watching. I will be putting links to the music and the data in this video in the description. Have a very nice day.